These are the notes for section 9.3, adding and subtracting rational expressions. Let's remind ourselves what rational expressions are. They are fractions with variables. We are adding and subtracting these rational expressions, so we need to have a common denominator. Looking at example 1, 5x over 12 plus x over 12. They already have the common denominator of 12. 5x plus 1x is 6x divided by 12. The 6 and the 12 we do need to reduce. 6 divided by 6 is 1. Keep that x there. 12 divided by 6 is 2. 1x divided by 2 or x divided by 2. Either one of those answers is acceptable. Example 2, x divided by x squared minus 9 plus 3 divided by x squared minus 9. Looking at the looking at the denominators first, they are the same, so we can add the numerators. X plus 3 divided by x squared minus 9. X squared minus 9 factors, so we're going to write x plus 3 as our numerator, divided by x plus 3 times x minus 3. X plus 3 divided by x plus 3 equals 1. In our numerator, we will have a 1, and our denominator is x minus 3. It's also acceptable to write 1 divided by x minus 3 without those parentheses in the denominator. Example 3, 2x squared divided by x squared plus 7x minus 8 minus x minus 1 divided by x squared plus 7x minus 8. We do have common denominators, so let's subtract our numerators. 2x squared minus x plus 1 divided by x squared plus 7x minus 8. That numerator does not factor. The denominator does, but because the numerator will not factor, there will be nothing to divide out. That is the final answer. Example 4, 1 divided by 6a plus 4 divided by 9b minus 5 divided by 2a. Looking at those denominators, the 6, the 9, and the 2 all multiply into 18. We need to look at the variables. The first fraction has an a in the denominator, the second fraction has a b, and the third fraction has an a. So our denominator is going to have to be 18ab. So we're going to start with 1 over 6a, and we're going to multiply by 3b over 3b plus 4 over 9b times 2a over 2a minus 5 over 2a times 9b over 9b. Carefully multiply your fractions. So 3b divided by 18ab plus 8a over 18ab minus 45b over 18ab. Looking at our numerators, we're going to have 8a minus 42b, all divided by 18ab. 8, 42, and 18 all divide evenly by 2, so 4a minus 21b divided by 9ab. Example 5. A minus 1 divided by a squared b minus a minus 2 divided by ab. Our common denominator is going to have to be a squared b, so we are going to multiply our second fraction by a over a. Multiplying the numerators, we're going to have a minus 1 minus a squared plus 2a, all divided by a squared b. Rewriting, so our a squared term is first, it's negative a squared plus 3a minus 1 divided by a squared b. Example 6, 7 divided by x squared plus 2. Go ahead and make that 2 over 1. Our common denominator is going to be x plus 2. Our first fraction we do not have to change. Our second fraction we're going to multiply by x plus 2 over x plus 2. So we have 7 over x plus 2 plus 2x plus 4 over x plus 2. Adding our numerators, 2x plus 11 divided by x plus 2. With example 7, we get heavy into factoring. Let's remember to use parentheses, so we're going to rewrite as 8 minus 1 divided by a minus 2 minus 3a plus 1. Now factor that denominator into a plus 5 times a minus 2. Both denominators have an a minus 2. So the fraction on the left, we're going to multiply by a plus 5 over a plus 5. Now we have our common denominators, so we will multiply our numerators. A squared minus a plus 5a minus 5, that's this numerator, minus 3a minus 1, all divided by a plus 5 times a minus 2. Combining like terms, we have a squared plus a minus 6 divided by a plus 5 times a minus 2. I'm going to factor that numerator into a plus 3 times a minus 2 divided by a plus 5 times a minus 2. A minus 2 divided by a minus 2 is 1. Our final answer is a plus 3 over a plus 5. Example 8, 2x squared divided by x squared minus x minus 12 minus 7x plus 4 divided by x squared minus x minus 12. We already have a common denominator, so let's subtract our numerators. 2x squared minus 7x minus 4 divided by, and now I'm going to factor that denominator a while, x minus 4 times x plus 3. Factoring that numerator, I'm going to ask myself what multiplies to negative 8 and adds to negative 7. Negative 8 and positive 1. I'm going to go ahead and rewrite 2x squared plus 1x minus 8x minus 4 divided by x minus 4 times x plus 3. Factor by grouping in the numerator. I'm going to factor out an x. It's going to be 2x plus 1 minus 4 times 2x plus 1 divided by x minus 4 times x plus 3. The numerator factors into x minus 4 times 2x plus 1 divided by x minus 4 times x plus 3. X minus 4 divided by x minus 4 is 1. Our final answer is 2x plus 1 divided by x plus 3. Example 9 is an equation. It has an equal sign, so we need to find out what x equals. I am not going to deal with getting a common denominator, so we are going to multiply each term by that denominator, x plus 2. So 5 over x plus 2 times x plus 2 over 1 equals 7 over 1 times x plus 2 over 1 plus 8 over x plus 2 times x plus 2 over 1. Each term I multiplied by x plus 2 over 1. Dividing before we multiply, get 5 equals, distribute here, 7x plus 14 plus, again, divide before you multiply, 8. 5 equals 7x plus 20, 2. No fractions anymore. Subtract 22 from both sides. Negative 17 equals 7x. Divide by 7 on both sides. X equals negative 17 over 7. By multiplying by the reciprocal, we were able to eliminate the fractions in the equation. We're going to do the same thing for example 10. This time, though, we need to multiply everything by 3x. So we're going to have 5x over 1 times 3x over 1 minus x over 3 times 3x over 1 equals 9 over x times 3x over 1. Reduce before you multiply. X divided by x is 1, so we have 15. Minus 3 divided by 3 is 1. X times x is x squared equals x divided by x is 1. 9 times 3 equals 27. We're trying to find out what x equals here. Subtract 15 from both sides. Negative x squared equals 12. Divide by negative 1 on both sides. We get x squared equals negative 12. When we square a number, we are never going to get a negative answer. No solution. Those are the notes for section 9.3, adding and subtracting rational expressions.